The paper of the day is The Nucleus of a Multiprogramming System. This paper describes the philosophy and structure of a multiprogramming system that can be extended with a hierarchy of operating systems to suit diverse requirements of program scheduling and resource allocation. The system nucleus simulates an environment in which program execution and input and output are handled uniformly as parallel cooperating processes. A fundamental set of primitives allows the dynamic creation and control of a hierarchy of processes as well as the communication among them. Basic attitude during designing was to make no assumptions about the particular strategy needed to optimize a given type of installation, but to concentrate on the fundamental aspects of the control of an environment consisting of parallel and cooperating processes. Author's first task was to assign a precise meaning to the process concept, that is, to introduce an unambiguous terminology defining what a process is and how it is implemented on the actual computer. The next step was to select primitives for the synchronization and transfer of information among parallel processes. Author's final decision concerned the rule of dynamic creation, control, and removal of processes. The purpose of the system nucleus is to implement these fundamental concepts: simulation of processes, communication among processes, creation, control, and removal of processes. Highlights: philosophy of a multiprogramming system with a hierarchy of operating systems. Second, program execution and I/O are uniformly as parallel cooperating processes. Programs on old systems were built for those systems. Almost impossible task to replace an OS. OS are built special purpose for batch processing, priority scheduling, RT scheduling, conversational access. Thus, the aim of building the nucleus is to make something extensible which is capable of adding functionality. The nucleus designers wanted to assign precise meaning to the process concept, select synchronization primitives to transfer information among parallel processes, define rules for dynamic creation, control, and removal of processes. Processes. It's an internal external processes. External program is a set of instructions. Internal is a process governing the execution of the program within a storage area. Peripheral is a hardware device with an ID connected to the data channel. Document is a collection of data stored on a physical medium, example punch cards, magnetic tapes, files, etc. External processes is the input-output of a given document ID'd by a unique process name. Coordination between internal and external processes is handled by the nucleus, which is an interrupt response program with complete control of I/O, storage, and interrupts. Process communication. Processes communicate through message buffers. Synchronization via send message, wait message, send answer, wait answer. Communication is vital and processes should go undisturbed in the event of errors of malicious and undebugged programs. One issue is that because the pool of buffers is finite, a process may consume all available buffers, preventing other processes from sending messages. A limit on the amount of buffers a process may consume is set. Process hierarchy. Need control strategies for operator communication, program scheduling, and resource allocation should be implemented as the processes. Arrange processes in a hierarchy where parents have complete control over children in order to maintain operations. All child processes must fit within the parent. Can be used as a strategy to limit system resources. Implementation. Communication is relatively expensive, around 2 milliseconds to have conversation, that is send, wait, answer. Process accounting start, remove take around 30 milliseconds, create stop around 3 to 4 milliseconds.